Apostrophe CMS onboarding series, adding extensions. Extensions are a way to easily add functionality to your project, whether by adding modules created by other developers or a set of self-developed custom modules that get installed into your project to get it going quickly. Apostrophe's own library of extensions also contains great examples for learning Apostrophe's codebase. For the final tutorial of our basic project build, we're going to install two different extensions. First, we will install the SEO extension. This extension is a good example of how a set of bundled modules can improve multiple core modules as well as modify the project layout template. Next, we will install the blog extension. In this case, the blog extension doesn't improve any core modules, but it provides a useful example of how to implement piece type filters, queries, and the extendMethods function when creating a new piece type. The amount of actual code creation in this template will be minimal, but you can switch to the sec 2-8-adding-extensions branch of the project repository like with the previous tutorials. It's linked below. Alternatively, you can just install the two extensions using the npm commands detailed and add the modules into the app.js file of your local project. In addition to other resources like blog articles and tutorials, the Apostrophe CMS website has a section for extensions provided by both the Apostrophe engineering team and outside contributors. The page is a great resource for learning about ways to expand the Apostrophe codebase. Once you find an extension that seems useful, you can click to read more information about the extension, find the installation instructions, or click through to the repository on GitHub to look at the code. The Add Apostrophe CMS SEO module adds meta fields to all pages and pieces, which provide useful functionality like Google Analytics support. In this section of the tutorial, we aren't going to focus on proper SEO practices or the content that this module adds. Instead, we will focus on two aspects of this module. First, how the SEO module accomplishes the installation of multiple modules, and second, how to modify multiple pages and pieces using improve and template injection. To install the SEO extension, we will go to the extension page and follow the installation instructions. There are two steps. First, from within the root directory of your project, run the npm install @cms/SEO command. This command will install the module into your npm_modules/@CMS folder and update your package.json file. Next, we have to open our app.js file and add it to our modules configuration as you would with any new project level module. A base URL is necessary for deploying an SEO extension enabled project to production. Adding one can be done either by using the apos_base_URL environment variable or by setting the base URL option during deployment. If the base URL is set during local development, you will see problems with asset loading and login. Like the other custom modules we created for this onboarding project, the top level of this package is an index.js file. Let's walk through the code starting with the options. The first property, alias, provides a quick reference to the module on the apos object. We covered this briefly in the creating widgets tutorial in this series when we accessed the columns helper function. Basically, instead of using apos.modules'*CMS/SEO, you can use the apos.SEO. You do not want to do this for most publicly available modules, so those that would be distributed to multiple projects, to prevent any kind of naming conflicts. The next property is I18N. This property sets up a namespace for localization strings for files in this module. This method of setting the namespace is deprecated, but still supported. Instead, within the I18N object, an apos SEO key should be added with the additional configuration supplied via an object of that key. In this case, the browser property is set to true. This makes the translation strings available within the view components of the admin UI when a user is logged in. Looking at the overall project structure, we can see that there is an I18N folder at the root level of the project. The JSON files in this folder provide the translation strings and do not need to be prefixed with apos SEO. However, within the modules, anytime these strings are used, you need to prefix with apos SEO : to fetch the translation from the correct folder. Following the options is a top-level configuration object that we haven't covered, bundle. It can take an object with two properties. The directory property takes a relative path to the directory of modules to be loaded. Looking at the npm modules/@CMS/SEO folder, we can see that the modules folder is in the same directory as the index.js file. The modules property takes an array of module names. In this case, that array is supplied by the function getBundleModuleNames, located at the end of the index.js code. Using this approach allows for the registration of any number of modules quickly. The initSelf and componentSelf configuration objects work together to add markup to the body and two sections of the head. First, three new components are added by the componentSelf method. The template for each component is located in the npm modules /@cms/SEO/views folder, where the name for the markup file matches the name of the function in the components object with HTML appended. This was covered in the Creating Widgets tutorial. From within the initSelf function, the module takes advantage of the prepend and append functions exposed by the @CMS template module. These functions specify where additional content can be added to the @CMS template views outer layout base.html file. You can examine this file to see where these injection points are with respect to the blocks that we covered in the Creating Pages tutorial. With these two methods, we are inserting the templates registered by the components method into the base layout file. Modifying that base layout file allows you to modify all pages and templates that are extending the outer layout base.html file without knowing the markup of the individual templates or having to add the module to every page individually. The nunchucks templates for each of the components are fairly standard. The views/404.html, views/tag-manager-body.html, and views/tag-manager-head.html all pull the @CMS global module options. The views metahead.html markup is slightly different. This same template can be used on a piece page or another page type, so it has to pull data from any of these sources. It then uses conditional logic to retrieve data from any of the possible sources to apply in the template. If there was also data being harvested and applied to widgets, data.widgets might also be needed to be pulled for desired data. The SEO extension bundles 8 modules that each improve a different core apostrophe module. By improving each of these core modules, the core modules and all custom modules in your project that extend these same core modules will have the same code changes. For 5 of the core modules, @CMS file, @CMS file-tag, @CMS image, @CMS image-tag, and @CMS user, the only improvement is to pass the SEO fields false property in the option to disable the SEO field enhancements for those piece types. This is necessary because the other modules of the extension, as we will see, improve core modules that these 5 extend, but it doesn't make sense for these 5 to add SEO data. The SEO-fields-global module of the extension also disables the SEO fields for the global piece type, but adds several other schema fields to a tab labeled with the apos SEO:*group translation string. In this case, rather than add a fields object directly, the object is being returned from a function that uses conditionals to check whether 3 different options have been enabled. Looking at just one of these conditionals, you can see it is checking the global SEO Google Tag Manager option. If that option exists, it creates a new field in the add object with the same name as the option. That field is then set to an object with a translated label, a field type of string, and a translated help string. Finally, the new field is also added to the Groups option for display on the proper tab. The options this code is checking can be passed to the @CMS global module from 2 different places at project level. In the README file of the extension package, it demonstrates enabling them by adding to the module configuration when activating it in the modules object of the app.js file. We could also elect to add them to the options of the project level modules @CMS global index.js file. Let's take a brief look at 2 last modules that the SEO extensions provides. The SEO-fields-page-type module enhances the @CMS page type module by adding a single relationship schema field. Enhancements to the former module also benefit the @CMS piece page type module, as the latter extends the base module. These enhancements are implemented using a fields method that returns an object instead of using just a plain static object. The method enables conditional field additions depending on options for each page type module. Similarly, the SEO-fields-doc-type module enhances the Apostrophe CMS doc type module. Enhancements here impact not just page type modules, but also the Apostrophe CMS piece type module. For the doc type module, the fields function returns an object that includes multiple schema fields, provided options.seo fields isn't set to false. The function also introduces an extra select type schema field if the extending module specifies an SEO canonical types option within an array of piece type module names or includes Apostrophe CMS page to encompass all page types. Such an addition enables piece type modules to identify a canonical link for a piece. Overall, this extension provides a good blueprint for how to modify all the page and piece types in a project. A similar strategy could be used to include any combination of core modules. For example, only improving the Apostrophe CMS widget type and Apostrophe CMS piece type modules. The blog extension adds a new blog piece type and piece page type to your project. Like the SEO extension, it uses the bundle option to make an additional module available. A main feature of the blog module is the ability to filter the posts in the piece management modal by publication date that uses both filters and custom queries. The extensions code will also allow us to examine the Pieces Filters option introduced in the Creating Pieces tutorial. To install the Apostrophe CMS blog module, navigate to the Extensions page and follow the installation instructions. After running npm install Apostrophe CMS blog in the root of our project, a number of follow-up steps are necessary. I'm not showing it here, but you would also need to add the Apostrophe CMS/blog page to the types array of the project level Apostrophe CMS page module index.js file. Unlike the SEO extension, the Apostrophe CMS blog module should be added to the bundles array of the project app.js file. The modules added through this package extend the Apostrophe CMS piece type and Apostrophe CMS piece page type core modules. For the SEO extension, all the modules improved rather than extending the core modules, so it was sufficient to add the base Apostrophe CMS SEO module to the module's configuration object. Adding Apostrophe CMS blog to the bundles can also allow you to use the two modules of the extension as a base to further extend your own custom modules without adding either of the extension modules to the module's configuration object. This extension is slightly more modest in scope than the SEO extension. The main index.js file adds the Apostrophe CMS blog piece type. It also uses the bundle configuration to load a module to provide the pages for the new piece type. Since it is only a single module, the name of the module is added directly to the bundles.module array instead of using a function that returns all the names in the directory. At the root of the extension, there's a helper file, queries.js, that we will examine when we dissect the main index.js file. The modules/Apostrophe CMS/blog page folder contains the index.js file for the new piece page type and also a views folder containing the expected show.html and index.html files, but also a filters.html file that contains the markup for the filters that users can apply to the pieces. Let's walk through the npm modules Apostrophe CMS blog index.js file. At the top, the file uses require to bring in two dependencies into the module, the day.js library and the queries.js helper file. Within the options, a label and I18N namespace are added. Additionally, the sort option is set to sort on the published at field in descending order from newest to oldest date. This impacts the order in the piece manager and on the index page. As covered in the Creating Pieces tutorial, the columns configuration object adds additional columns to the piece manager. In this case, it adds the value of the published at schema field. As outlined, this extension provides a ready-made way to filter blog articles based on a date, but not much else. As such, the fields configuration object only contains a single field, published at. For actual blog pieces, you would have to add additional fields like author and an area with widgets for content area. The filters configuration object adds 4 different filters to the piece manager. As covered in the Creating Pieces tutorial, each of the filter objects take their name from either a schema field name or from a custom query builder. In this case, all four use a custom query that is supplied by the queries.js helper file that was required at the beginning of the index.js file and added just after the filters. This adds the object returned by the helper file to the queries configuration customization function. We'll look at that helper file next. Finishing off the index.js file is an extendMethods configuration function. The new instance method is the function that creates a new document when you save your piece. In this case, it checks that the new piece has a published at field, and if not, it adds one with the current date. To reiterate, the filters configuration object can take either an existing schema field name or a custom query builder to filter pieces. In the case of these filters, none correspond directly to a schema field, and all require examination and/or parsing of the published at field. This file provides the custom queries for each of the added filters. We will step through two of the filters. The filters for year, month, and day are all very similar. The filter for future is slightly different, so we will cover that one and the year filter. The query builders for each filter are defined as named objects within the builders object. Here, this code snippet provides the builder for the future filter. Each of the filters in this file are initialized with a default value of null from the def property. They each also have three functions: finalize, launder, and choices. We'll start with the choices method as it makes it easier to understand the finalize method. The choices returned by the choices method are presented to the user in the filters dropdown of the piece manager. When the user selects one, it is set on the query object. Again, by default, this filter has a value of null, which will leave the blog pieces unfiltered. Selecting to filter for only articles to be published in the future will set future true on the query object, while selecting for already published articles will set it to false. The finalize method runs at the end of query building prior to processing by the database. There are also pre-finalize and after methods that run prior to the finalize method and after database submission, respectively. You can read more about them in the documentation. The first thing this method does is retrieve the value of the future key from the query object. The first conditional then tests if the user is able to edit draft versions of the pieces. If not, then the value of future is set to false, allowing the user to only see blog pieces that have already been published. If the next conditional, future strict equality null, tests positive, then the query will be returned without any modification since the user wants to see all pieces. Finally, the method gets the current date using the day.js library and modifies the query to require the value of the published at field to be greater than the current date if future is true, or less than if false. Note that the $GTE and $LTE are MongoDB comparison query operators for greater than and less than, respectively. The launder method validates the values that are passed as arguments and returns true if valid. In this case, the method passes the value through a method exposed by the @CMS launder module. This module actually attaches an instance of the standalone launder package that can be used in any project. The method being used allows the return value to be true, false, or null. Actually, it also allows a lot of other values like T for true. See the package linked below. Like the future filter, the year filter has finalize, launder, and choices methods, plus it sets the default choice to null. The finalize method is significantly simpler for the year filter as compared with the future filter. It checks the query object to ensure that the year is set and returns without modifying the query if it isn't. Otherwise, it adds regex to the query to detect the year value at the beginning of the piece published at field value. The choices method populates the user choices by performing a database query and then creating an array from the results. The value of the allDate variable is set by modifying the query with the toDistinct query method. This query method returns an array with all the published at values across all the blog pieces, with each value only appearing once. It then takes each full date, extracts just the year, and pushes that value to the years array, finally sorting the array before returning it. Additionally, in order to allow the user to remove the year filter and have blog articles from any year appear, the years array is defined with a first item that passes null as a value to the finalize method. The launder method in this case passes the date through the @CMS launder module string method, It then takes a sanitized string and uses the JavaScript match method to test that the value is a valid 4-digit year. The filters for months and days are almost identical, except for some slightly different parsing of the published at and changes in the regular expression used in the launder method. To summarize, you can create a custom filter for any user submitted value, like part of a date, by providing 3 methods that parse and launder the values to provide choices that can then be used to identify a subsection of documents. The custom filters can then be used both in the piece manager, but also in the index.html piece page type to display a subset of the pieces. The blog page module implements the pages for showing your blog pieces. The index.html file also demonstrates how to implement filtering that can be adapted for use on any piece index page. The primary takeaway from this file is how filters are added and modified in the piece pages. Within the options object, 3 of the 4 custom filters are added to the page. This allows filtering of the pieces that are included in the data.pieces object that is delivered to the index page through adding query parameters to the page URL. Within the extendMethods configuration object, there are 2 core methods being extended. Again, as was covered in the Creating Pieces tutorial, the method being extended should take _super and any arguments that were passed to the original method. In this case, we are modifying the query object that is being passed to the filters of either the index page for the index query method or the individual show pieces with the show query method. In both cases, we override the value of the future key in order to exclude an unpublished blog pieces. This same extendMethods function can be used at project level to change the value of future to null or true. For example, you could check the user's permissions, like was performed in the main piece index.js field, and allow users who can edit the piece type to see unpublished articles. The index.html and show.html files are fairly standard for piece page types, and for more in-depth explanation, you can look at the Creating Pieces tutorial. Both templates extend the @cms/template/views/outerlayout.html file. The index.js file imports the macros.html file from the @cms pager module in order to paginate the pieces. Within the index.js file, there is a loop for piece in data.pieces to step through all the pieces. Since the filters change the data.pieces object, no changes have to be made in order for the content to be filterable. The show.html page is also quite standard, simply displaying the data passed through the data.piece object. Unlike our past examples, the index.html also imports another nunchucks file, filters.html, containing a fragment to be rendered on the page. This render call passes 3 arguments. First, it passes the data.piecesFilters object that contains the values generated by the choices method of the query builders. Second, it passes the URL query parameters of the current page, data.query. Finally, it passes the current page URL, data.page._URL. In the filters.html file, we will just look at the year filter markup, since the markup for the month and day filters is very similar. Within the fragment, the available pieces are passed as data.filters. For each year, the template generates a list item. Inside this list item, a hyperlink is added. The text of the hyperlink is the year itself. Additionally, the font style of the hyperlink changes if the current web page's URL includes a year query parameter matching the year in the current iteration. The href attribute for the hyperlink is set using a macro called here that is defined at the top of the file. In nunchucks, macros act like methods, taking multiple arguments and returning some value. In this case, the macro takes the current page URL as the first argument, and an object containing the date, either year, month, or day, as the second. It uses these values to create a new URL by piping the current URL into the build filter. The build filter then appends the data from the past object to the URL as query parameters. You can read more about the build filter in the nunchucks documentation. This then gets passed back to the hyperlink. When the user then clicks on the link, the browser navigates to essentially the same page, but with the query parameter added. Apostrophe intercepts this query parameter, and it is passed to the finalize method of our filters to populate the data.pieces object with only the documents that match the filter value. The loop in the index.html filter steps through each of the returned pieces to output the final markup on the page. In this tutorial, we explored the addition of two different extensions from the Apostrophe library to our project. This exploration offered insights into the bundle configuration property and the implications of using extend versus improve for modifying core modules. The tutorial also facilitated a deep dive into filters, queries, builders, and pieces filters. Now that you have completed our series of onboarding tutorials, we welcome you to check out other tutorials on our documentation site to learn even more about Apostrophe CMS. You can also watch some of the other great videos on our channel. Make sure you're subscribed so that you get notified when we post new video content.